Okay, ladies and gentlemen, so Chapter 6, we've been dealing with equations. We're in a similar and not exact but related area. We get into these things that we call inequalities. Okay, and so I'll get to what inequalities are in a second, but the three main ideas that we're going to need to be able to do, or objects that we need to be able to accomplish in this section, first of all, are to identify and use the inequality symbols. Many of these will be reviewed. Identify solution sets. And then thirdly, to be able to solve and graph inequalities. And I'll show you, in many cases, giving you the steps of how to do each of these things. Now, first of all, an inequality is a mathematical sentence that contains any one of these symbols. Okay? Now, you'll notice here the equal sign itself is not in there. That would make an equation. If you have a sentence that you're using one of these, then you have an inequality. Okay, and in this case, your symbols, hopefully you recall, greater than, less than or equal to, less than or equal to, and then this one here at the end is not equal to. Okay, so we're talking, and that's the equal sign with a slash through it, which I have used in previous problems when things have not been equal to one another. And so hopefully you recognize that from things that I've used. But that means two things are not equal to one another. So for example, I have 4 and 5, and I'm going to write or use this to set up an inequality. Well, I actually have, in this particular case, I have some choices of things I could put in, because as I go across here, 4 is greater than 5. Well, no, it's not. I would have to go this way. So 4 is less than 5. This would be one inequality symbol that would make this relationship state a true, or make a true statement. 4 is less than 5. The other one that I could use in this case, or another one, is 4 is less than or equal to 5. Okay. One of the things about inequalities is we have these situations where we have a little bit of an or going on, and so when we're using that, one of the two things has to be true. Either 4 is less than 5 or 4 is equal to 5. In this particular case, 4 would be less than 5. Therefore, we could use this less than or equal to symbol if we wanted to, and that would also be a true statement. The other one that we could use of these particular statements to make a true inequality, let me go ahead and get rid of this. I could actually, if I wanted to, use the not equal to, because 4 is not equal to 5, correct? So that would make this a true statement. Okay. So in certain situations, we may have multiple inequalities that we could write depending on what the numbers are. Now the other part, or the other key vocabulary term we have to deal with in this particular case is what we call a solution set. Solution set is the value or set of values. There could be more than one answer to a situation that makes a statement true. The solution set can be shown by graphing on a number line. That's one of the things that we're going to do through here. And so the first thing we're going to do is we're going to complete using an inequality. So in this particular case, we want to figure out, we're going to fill in the blank basically, which of our inequality symbols that we're given applies to this situation. 13 minus 9, is that greater than or is that less than 6? Okay, so we have those choices, so we have to go ahead and subtract 13 and 9. Well, 13 minus 9 is 4. Okay, so what we're actually comparing here is 4 and 6. Okay, so what is the true inequality symbol, or what is the inequality symbol that will make this into a true statement? Well, in this particular case, we will have to use the less than symbol. Remember that this guy here, the alligator or Pac-Man or whatever you want to call it, if you need that. If I go with Pac-Man, let's see if I can draw a good one. Yeah, not too bad. Pac-Man eats the larger item. Okay, so let me go ahead and less than. Okay, but I don't really want you drawing Pac-Man. So, okay, we just have to realize that the mouth eats the larger thing. Okay. 2 times 8 compared to 10. Well, 2 times 8 is 16. We are comparing that to 10. Well, which of my solutions works? Well, that would be the greater than symbol because 16 is greater than 10. So 2 times 8 is greater than 10. Okay, so simplify down, stick on the appropriate symbol. Now, important fact, and this is one thing that we get when we're getting into this this part of your mathematical lives, is understanding that in life and mathematics, it is common to have more than one solution to a situation. This should actually say 1. Okay, there is more. Now, there are many cases where we only have one solution, but in many cases, we have more than one solution to a situation. And here are a couple of examples of real-life inequalities. To ride many of the attractions at an amusement park like Cedar Point, a person must usually be a minimum of 48 inches tall. Okay, which tells me that anybody who is 48 inches and above, so 48 inches and above, any of those people can ride the rides. Okay, it would be silly, because one of the things we say, well, how tall do you have to be to ride at Cedar Point? Well, 48 inches. Well, if we just say 48 inches, that means that somebody who is 48 inches, only the people who are 48 inches tall are allowed to ride the rides. The people shorter and the people taller would not be allowed to ride the rides. Okay. Same thing. To drive a car in Michigan, you must be at least 16 years old, and I'm ignoring all of the newfangled testings and things that have to be done in different. I'm just generally saying, you got to be 16. All right. Well, it's 16 and older. Okay, 16 and above are the people who are allowed to ride or to drive. It would be silly for somebody to be 16 and allowed to drive, but people who are younger and people who are older are not. So these are both situations where we have many answers. Okay, 16 and above, 48 and above. So now we're going to express these using an inequality. Now you'll notice your steps for writing an inequality are over here on the right. Please use them as you're going through here. So we're going to write an inequality. It's a mathematical statement representing our situation at Cedar Point. Okay. So now, choose a variable to represent the solution set. So the solution set in this case is all of the heights of people who are allowed to ride the ride. So I'm going to use h. Okay. I'm going to use a variable. You may pick any variable you want unless you're told a specific one. Okay. So I'm going to use h to represent height. Identify the reference number, or the reference point. In this case, it's the 48 inches tall. That's the value that we're comparing to. Okay, and then we're going to insert the inequality system or inequality symbol that makes the statement true. Well, that's when we go back. Let me go back a couple slides to all of. I'll open these up. Which of these symbols makes the statement the most true? Okay. Well, I want the people's heights to be anything equal to 48 inches, but also larger. Okay, 49, 50, 51, and so on. So I'm going to use greater than or equal to, because anybody who is greater than 48 inches or equal to are allowed to ride the rides. Okay. Now, if I were to put this the other way around, if you wrote this, that would be the same thing, or if you used a different variable. Okay. To drive a car in Michigan, a driver must be at least 16 years old. Well, I'm going to use D for driving age, and in this particular case, it works the same way. I want anybody who is 16 or older, 17, 18, 45. Those all work as well. So we're going to go greater than or equal to. If you switched this inequality around and wrote it this direction, these are the same inequality. These up here, same inequality. Okay. Now we're going to graph our inequalities. And this is, again, this is a set of steps to follow. Okay. First of all, draw a number line. Okay. When we graph inequalities, we put them on number lines. I've already got my number line set up here, but you may have to draw one of your own. Include your reference point, in the Cedar Point example, and put it somewhere near the middle of the line. 48, 49, 50. You can. I'm not going to label every line. We know that the ones I skip in the middle. Just make sure you go up at a constant rate. This one's going to be 46. There's my 47. This would be 45. Okay. Down here, my reference point was 16 for ages, 17, 18, 19, 20, and if I go the other way, this will make this one 14. Okay. Go up at a constant rate. Okay. Draw a circle on the line at the reference point, an open circle for less than or greater than. A shaded circle if you have the equal to's. Now in our particular case, we were using h is greater than or equal to 48. So that tells me automatically I am using a shaded in circle. Well, and the reason we use the shaded in circle is because 48 is part of the set of people who are allowed to ride the rides. If the people at 48 inches were not allowed to ride the rides, we would use the open circle. Okay? Just like down here when we're doing our 16, we had, let's see, age, right? What did I use for? I used D, okay, for driving age. D is greater than or equal to 16, okay? Again, equal to, and the reason that we're using the shaded in circle in this case is because 16-year-olds are allowed to ride the ride, or to drive the cars. If they weren't allowed, okay, let's say that we said, one of the other inequalities we could say here is, well, I'll come back to that, okay? Shade the line in the direction of the values that make the statement true. So in this case, we are going to shade in the direction of people who up here are allowed to ride the rides. So all I'm going to do is I'm going to take, and I'm just simply going to make a little squiggly line this direction that tells me that everybody over here, starting at 48 and to the right, these are all of the people height-wise who are allowed to ride the rides. Okay. Driving age, I'm going to shade in the direction of people who are allowed to drive. Okay, those are the people who make the statement true. Okay. Let's see, any other points that I want to make? No, I'm not going to make, at least not in that particular case. Let's go ahead and go on, and I can deal with individual questions as they arise. Solving and graphing inequalities. Okay. And the nice part about solving inequalities is we do them the same way that we did in our previous section. Okay, isolate the variable by getting rid of the addition in this case. So how do I undo plus 7 while I subtract 7? I do it from both sides of the inequality. 7 minus 7, well, these cancel out. My x comes down. My inequality symbol comes down. Negative 10 minus 7, minus 7 is negative 17. Okay, not negative 3. So now, negative 17 becomes my reference point, so I will put that in the middle of my line. This would be negative 16, negative 15. Remember, because I'm on the other side of 0, that's going to change my my direction of my numbering. Okay. Now I need a dot. Well, what kind of dot at 17? Negative 17 do I need? Well, I need an open dot. Okay. Actually, you know what? I will just draw it. I need an open circle. Because what this is telling me that negative 17 is not part of my solution set. It's just my number that we're referring to. X is less than negative 17. So my solutions, my number for my solutions are things that are smaller than negative 17. So on my number line, I have to look at this and go, okay, what direction are values smaller than negative 17? And don't get this backwards, because a lot of people are going to try to shade to the right, and that's not correct. Okay, we know that things to the right are always bigger than things to the left. In this case, numbers that are smaller than negative 17 are to the left on the number line. And so this would be the graph of my inequality. Okay? Add 11 to both sides. I'm going to go ahead and go quickly here. Okay, I'm just undoing subtraction. So my 11s cancel. T comes down. Less than my symbol comes down. 11 minus 3 is 8. Okay, so 8 will be my reference number. 9, 10, 11, 12. 6 would be here. Got an equal to going on, so I will need a shaded in circle. So I will go ahead and shade this in. T is less than 8. Well, things to the left again of 8 are smaller than. All right, time to practice. Please, please, please come get help if you need it. Good luck.